me share my screen. In this particular topic, I'm going to talk about managing big data. Under that, the topic is Apache Yarn. So, I will discuss about in detail what is Apache Yarn. So first, we'll see here what is Apache Yarn. Basically, this topic is dedicated to Master of Technology under VTU for the semester third. So for the 2022 syllabus pattern. More or less the syllabus is same. Here we are talking about Apache Yarn. Apache Yarn is nothing but yet another resource negotiator. This is, you can say, the provide the upper layer service of to the MapReduce. Early Earlier when MapReduce was there, then that time MapReduce itself only was doing the resource management and the batch processing or parallel processing of the larger data set. But the problem was managing resources and doing the processing parallelly was quite difficult and not proficient. So the MapReduce 2, you can say the launched Hadoop 2 launches enhancement of a MapReduce as a yarn, right? So yarn is the one, you can say the cluster resource management, which is provided by the Hadoop 2 and which is supporting the distributed computing paradigm. And yarn basically manages the cluster resource and provides the application platform interfaces, but users typically interact with the higher level of framework like MapReduces, Spark, and Taze, which runs as yarn applications. Additionally, tools like Pig, Hive, and Crunch operates on these framework without direct interaction with yarn. This chapter basically introduces yarn features as a foundation for the later discussion on the Hadoop's distributed processing framework. If you observe this diagram, in this diagram, the application layer is what? MapReduce, Spark, Tej. These are the basically handling the larger data set to process. And in between, Yarn. Yarn basically maintaining the, you can say, cluster as a resources, as a node, right? And storage, basically Hadoop distributed file system and HBase. Under that, very important topic which we have to do, topic is anatomy of yarn application run. We'll discuss about here how one particular yarn is providing these services. Like if you observe here, yarn is providing the core services via two types. One is long running daemon, a resource manager. One is resource manager per cluster. Observe here, plus per cluster to manage the use of resources across the cluster, and the node manager running all the nodes in the cluster to launch the monitor container. If you are aware about the clusters, then you know there is a nodes. This means connection of the systems. Everything is there, right? So a container executed is application specific process with a constraint like set of resources, you can say IO, memory, central processing unit, and so on. Depending on how yarn is configured for the particular task, and container may be a Unix, remember here, Unix process or a Linux C group. If you observe this diagram, in this diagram, application client from the client node is submitted to the resource manager uh, to allocating through resource manager node, and this step is called as submit yarn application from the resource manager node. As I said here, this is providing the resource manager and the node manager like to monitoring the container. So basically the node manager under the container. So we start the container and we launch it and the container application process under a node manager node. And this particular application process is providing the feedback, which is allocating the resources. Like if any node is getting failed, then this will provide the information to resource manager. The resource manager will take care of that by making the replica, right? And then the process. Start container as a node manager, and their container application process launches and node manager. This is complete diagram for the to defining the its core services via two types like resource manager and the node manager. And the both are working on the cluster and monitoring the container, right? So I hope it is clear with you. To run the application of Yarn, a client contact the resource manager and ask it to run the application master. The resource manager then finds the node and manager that can launches the application master in the container. As you have seen in that diagram, and precisely what the application master does once it is running depending on the application. It could simply run computation in the container. It is running in the and return the result to the client. Or it could request more containers from the resource manager and use them to run the distributed computation. The later the latter is what the MapReduce yarn application does, which we will look at the core detail anatomy of MapReduce run. Notice here in diagram, the yarn itself does not provide any way for the part of the application like client, master, and process to communicate with one another, right? Most non-trivial yarn application use some form of a remote communication such as Hadoop's remote procedure call layer to pass status, update results back to client, but these are the specific application. Now, in this diagram, resource request and the uh, node manager, task, everything we are going to discuss. Okay. So Yarn has a flexible model for making the resource request. A request for a set of containers can express the amount of computer resource required for each container, memory, CPU, as well as locality constraint for the containers in the and that request locality is a critical to ensuring that distributed data processing algorithm use the cluster bandwidth efficiently. So Yarn allows an application is specific locality container for the containers it is requesting. Locality containers can be used to request a container of a specific node or rack or anywhere on the cluster of rack, right? Sometimes the locality constraints cannot be met, in which case either no allocation is made or optionally the constraint can be loosened. For example, if a specific node was requested but it is not possible to restart a container on it because other containers are running on it, then Yarn will try to start a container on a node in the same rack of, or if that's not possible on any node in the cluster, in the common case of launching container process of HDFS block to run map task map reduce say the application will request a container on one of the node hosting the block 3 replicas or on a node in one of the racks hosting the replica or failing that on any node in the cluster. A yarn application can make resource request at any time while it is running. For example, an application can make all of its request upfront, or it can take more dynamic approach whereby it requests more resources dynamically to meet the changing needs of the application. Spark, basically Spark we will learn in the last, like Spark is advanced feature to process the larger data set, right? Based on RDD, I think. So we'll learn about that. Okay. So Spark takes the first approaching starting a fixed number of executor on the cluster. MapReduce, on the other hand, has two phases. The map task container are the requested upfront, but the reduced task container are not started until later. Also, if any task fail, additional containers will requested to fail the task can be rerun, right? Application lifespan. So the lifespan of the yarn application can vary dynamically from the short-lived application of a few seconds to long-running application that runs for days or even months, rather than the look at how long the application runs for its useful categorized application in terms of how they map to the job that cluster run. The simplest case in one application per user, which is the approach that map reduce takes, right? And the second model to run, in that you can say that these are the process of resource manager and non-manager only, right? The second model runs application per over workflow of or a user is session, possibly an unrelated job. This approach can be made efficient than the first, since containers can be reused between job, and there is also potential to cache intermediate data between jobs. Spark is an example that uses this model. The third model, long-running application that is shared by different users, such as the application often act in some kind of a coordination role, zookeeper, you can say, right? And for example, Apache Slider has a long-running application master for the launching other application cluster on the application cluster, right? And this approach is also used by Impala. Basically, it's a query language processing, and to provide the proxy application that the Impala daemons communicate with the request cluster resource. The always on application master means that the users have very low latency response to their queries, since the overhead of starting a new application master avoided. Now, the target is how anyone can build the yarn application. So writing yarn application from the scratch is fairly involved, but in many cases it is not necessary, as it is often possible to use the existing application that fits the bill. For example, if you are interested in a running direct cyclic graph tag of a job, then a Spark or These is appropriate. Or for a stream process, Spark, Samja, or Stormwork. There are a couple of projects that simplify the process of building Yarn application. Apache Slider mentioned earlier makes it possible to run existing distributed application on Yarn, and users can run their own instances of an application such as HBase on the cluster independently of other users, which means that different users can run different versions of the same application. A slider provides control to change the number of nodes an application is running on, and so suspend then resume running application. Apache Twill is a similar to slider, but in addition provides a simple programming model for developing distributed application on Yarn. Twills allows you to define cluster process as an extension of a Java runnable, then runs them in Yarn container on the cluster. Twill also provides support for, among other things, real-time logging, log events from runnable are streamed back to the client, and command messages sent from the client runnable. In case where none of these options are sufficient, such as an application that has complex scheduling requirements, then the distributed shell application that is part of Yarn project itself serve as an example of how to write Yarn application. It demonstrates how to use Yarn client APIs to handle communication between the client and our application master and the Yarn demands, right? I hope this is clear with you all. This is all about the anatomy of a yarn application with the help of resource manager and node manager and so many other categorization here I listed out and their terminologies I listed out. So we can go through that also. And if you are interested to know that MapReduce 2 on Yarn improves the scalability, resource utilization, and flexibility compared to MapReduce 1, right? And here MapReduce 1 Java track and Yarn, Yarn is using resource manager, application master, line server. There is a task tracker here, node manager slot. Here is a container. These are the few differences between the Hadoop first and Hadoop 2, right? Yarn was the design to address many limitation of a MapReduce one. The benefit of using is scalability, as I told you, right? Availability, resource utilization, multi-tenancy. So if you observe here in scalability, if you are working on the MapReduce, since they are only managing the resources and processing the data, then the limited of nodes like 4,000 nodes and 40,000 tasks due to job tracker bottleneck. But when it comes to Yarn, they scale up 10,000 nodes and more than lakhs of tasks by distributing the management across the resource manager and application master. Availability, since you know the scalable lack is there. In order to that, MapReduce one having lack of high availability due to centralized app tracker, but here you will getting the always available due to fault tolerance. You have seen, I think, heartbeat. I'm showing you again here. This diagram observe here. From here, it is reporting the any fault is occurring. This is right. Okay. And the resource utilization here is fixed and here is a dynamic. Multi-tenancy runs on only MapReduce job, but here supported distributed application. As I told, Spark there is right, and this is all about scheduling yarn. If you want to learn scheduling yarn, then in real world cluster resource are limited, and application must waits for their request to fulfill the yarn scheduler. Allocates resource based on the defined policies. Yarn provides the three scheduler with the configurable options, and these are the FIFO scheduler and fair scheduler and one more and capacity scheduler, right? So this we will learn, and through diagram, I think it is better to learn. This is FIFO first in first out scheduler. Here a graph between utilization and time. There are two tasks submitted, and which task is come first that will assign. Okay, capacity based on their size, right? Again, wherever the spaces are available, that particular task will get assigned, right? Paired scheduler, it's good that to you can say based on these two uh, share pool or queue, right? Based on that, and the details are given here. I hope this is clear with you all. And for next topic, we'll meet in next video, right? So for this, I'm stopping here. Thank you so much.